over, there we go, is, you know, hello, this is me. This is what you're going to learn type of thing. But yes, my goal is to have classes recorded. And thank you for reminding me. Okay. I am not the guru. We're on a learning journey together. Okay. I'm not going to stand up here and say I know more than anybody. I've just lived longer. I've made more mistakes than some of you. Okay. All right. Yeah, we have a few folks that are in this class that are using it to brush up for some certifications that are already industry professionals. And I'm hoping to tap into their expertise for some of this class so we can actually, share the knowledge of what it's like out there. Okay. Because what I did at Foster Farms in my entire career is, I won't call it dated, it's different. We didn't use Cisco switches. So I really don't know how to manipulate a Cisco switch, but I do know how to use other kinds of switches and other tools that are very similar, like VYOS, and then there's the Ubiquity. I know how to use those at the same level, but it's just a different thing. It's just a different way of doing the same thing. Okay. But understanding the command line is important in networking because you actually use a serial device to connect your notebook to a switch, and then you manipulate it via the switch. And that's another thing I would like to, maybe when we make the cable, we can actually do some of that in the classroom. I'm hoping, because not everybody has a switch they can play with. And watching it is one thing, doing it is another. Okay. So if you have extra networking stuff at home or need to build out your own home network, I would encourage you to do it. You can also do it with the virtual arena. In VMware, you can create several virtual machines and create your own domain. And you can create a bunch of Windows boxes, a couple Linux boxes, and then make it all work. You can make Pixie boot work and all sorts of things. So it's like having physical devices, but not. You're not actually plugging cables in. It's just all virtual. Okay. All right. So let's go back to our IP addresses here. So when we do things and we're sending out a ping to Google, like for example, let's use my domain right now. Let's do NS lookup on phillipsd.com. And what do you see? Here's my IP address. That's my actual IP address. So if I copy that and put it into a new browser window and use the IP address, guess where it takes me? This is what we call DNS, it's domain name system. It basically takes those digits, and you will find these digits are always in groups of 3. There's a reason for that. This is IP version 4. How would you like to surf the web by using only numbers? Yeah, okay, I want to go to a DNS server, so I need to go to 1.1.1.1 and go there. Okay, Cloudflare, or hey, I need to go to Google. What's their IP address? I forgot. Let me go look it up. That's why we have DNS. Okay, so it's resolving these IP addresses to names. So that's one of the core services that the network provides. Okay, so everything has got an IP address. And one question came up, is that Android randomizes it? That doesn't mean anything, because when you're using a cell phone, they're already tracking you, because the provider for your phone service, your 3G, 4G, or 5G, already has all your information. So whether or not it's randomized doesn't matter, okay? Because if you have a phone that is truly not connected to a phone service, well, then the randomized, then you have a tablet, and yeah, it's not going to hurt anything, okay? It just keeps things. You're going to have IP addresses, and the security. What I've noticed in the discipline of networking, network administrators used to be just network administrators. Well, what has happened over time is the network administrators are now phone guys because they're doing phone voice over IP. So network admins also do phone stuff. Network admins are being also brought into the world of security. So networking is a good base to build out what you want to do if you don't know what you want to do. Okay. All right. And there's Alex said, if you use the IP address, if you monitoring the chat, you can see 142.251.32.110. That takes you to Google. Okay. Same thing, but who's going to memorize all that? We just remember google.com. Okay. So that's there. And then, all right, I'll lose my train of thought here. So ping, you got DNS. Ping is special. If I do man on my Linux box here, this is how you look up information on Linux and Mac. You use the man pages. So if I do man on ping, it tells me all about ping and what it can do and how it works. So you can actually make it audible, broadcast. You can, how many times you want to do it. When you run it on Linux, it runs forever. But when you run it on Windows, it goes 4 times and stops. So when Microsoft rewrote ping, they put in the count. You can put in timestamp, and you can do flood ping. This is basically using versions of ping is how you do your denial of service attacks on websites. You can do interval, where you want to send it. So you can see it just goes on and on and on and on. And does anybody know all the options? Probably not. You just look it up. You're going to use what you need, and then you're going to forget, and then you're going to go on. But if you use it over and over again, you're going to remember. Now, one of the things you can do with ping is change the size of the packet. Okay. So basically the default is fairly small, but you can actually change it to be a monster, really big packet. And then what happens is companies like Google completely ignore you. They say, sorry, your packet's too big. You're a bad guy. They ignore you. Okay. So you can play around with ping on your machine, and on Windows, you would, to get the help, you type in ping /?, and it gives you the helps for the Microsoft. On Mac, it's like Linux. You just use ping and then type in man space ping. Man pages may not be installed on your Mac. I don't know. I don't have a Mac. I've never had one, and I can't justify, paying a premium for a computer when I can do the same thing on Linux for, a third the cost. Okay. And, but if it's given to you, sometimes you have to learn how to use it. Like, I like my tower I have in my office. It's got 256 gigabytes of RAM. So it makes it awesome for virtual machines. I can run, 20 different virtual machines all at the same time. Okay. So it's, when you do virtual machines, you need RAM, just lots of RAM. It's great to have multiple threads. Like But it's more important to have RAM. Okay. All right. Now, what I will do is kind of, oh, did anybody guess what this thing was? This is that thing that looks like a cup holder. Well, I'll show you. I want you to consider the days when you had to dial up. It's called an acoustic coupler modem, if you can see that. You put your phone on the acoustic coupler and it would take your ones and zeros and turn it into an audio signal so you could send it over the phone. Yeah. How would you like to do computing like that? Who even has a dial-up phone anymore? Yeah, they're getting rarer and rarer. Okay. And it went 300 baud, which was slow according to today's standard. The good old days weren't so good. Yeah, we had a lot of issues. Like I've been on a pager since they were invented. So in the 80s and in the early 90s, you'd get this tone pager and it would just make a noise. And you'd have to find a payphone, call to the mothership, say, hey, where do you want me to go? What do you want me to do? And they said, oh, we need to have you connect to a customer's computer. So you brag out your acoustic coupler modem, you stand in the phone booth, you connect it, and you get your old luggable thing, weighed about 20 pounds, boot it from the floppy and dial in, look at what they need to fix, you fix it, and then it was a pain. Okay. Took forever. Nowadays, you've got all sorts of tools at your disposal to make your life much easier. And which is why we can do Zoom classes. The technology we have today wasn't even thought about when I got started in it. People didn't have the whole idea of getting video onto the dial-up modems was just, there wasn't enough bandwidth. Okay. So now we have bandwidth galore because of fiber optics. Okay. All right. DNS. Now, how many have a router at home? Most of you probably have some sort of a router, right? How many have actually manipulated the router and had to configure it accordingly? Say you're a gamer and you had to get in there and fix it, right? Yeah, that's part of what this class is about. Is like, what did you do? Did you open up a security hole? Maybe you did. Did you set up a firewall so you can block it? Maybe you didn't. So in the world of opening up ports in our world of networking is problematic. Okay. If you have a firewall that's blocking incoming traffic and then you open a port so you can do something, well, the bad guys can find it too. The problem with life in general right now is that when you provision a box on the internet, it's going to get hacked. Okay. And if you go to the Jeremy site, let me show you something. You scroll all the way down to the bottom. See that funny little world? This is a service that for the time being is free. Now, I want to ask you, why are people from China and Malaysia hacking or accessing my website at Jeremy?
On a VPN. I was kidding.
Yep. It's and look, that's in the middle of the ocean. That's probably a randomized IP. But I do this as a demo because on my web server, it's actually a shared web server for jmk.net, and they have some pretty sophisticated things. So this is called GeoIP. I can find out where you are. And GeoIP, if you subscribe to the service, it's really accurate. So you're getting, so if somebody says, hey, yeah, I can't make it to school today for whatever reason, the IP address says they're coming from San Diego, and yeah, I can understand why you're not going to make it. Okay. All right. Now we have a lot of robots that are on the web that go out and crawl the web to create links. That's how Google does its thing. They've got crawlers all over the place. There's some really interesting computer science going on at Google and at Amazon. And where things are going is, I'm going to stop my share for a second and draw another little picture on the board to explain where your future is. Okay. And I'm on the back porch of my career. You're on the front porch of your career. Okay. We have these providers. We got Google Cloud, right? We have Azure. And we have, of course, AWS. And there's other companies out there that are in this space, but let's talk about these big ones. Okay. If you know this stuff and you're certified in these things, you're going to get a job. But you really can't go to school for this stuff because you have to know a bunch of stuff before you even start this. Networking is one of them. Okay. You really have to understand networking to be good at this cloud play. I want you to think about the lights that are on over your head. Do you have a generator in your house? No, you rent your electricity from an electricity provider. Okay. That's where computing is going. You are going to end up paying X dollars a month for the privilege of getting to your stuff. Microsoft is moving that way. It's just a matter of time. Well, Google, if you use Gmail and you use all their stuff, you are the product. Because if you've ever read the end user license agreement for Gmail, you've given them permission to scan your email so they can find information about you and send you targeted ads. So they all do it. Microsoft does this. Apple does this. All these companies harvest all this information to get you to spend more money on stuff. Okay. This is where the future's going. And what kind of technologies that you need to know to be able to make a living manipulating stuff in the cloud? Well, the reality is networking is step one. You really got to understand networking at a lot of different levels. Okay. Because the big thing in networking now is called SDN. Okay. It's called software defined networking. Just as I showed you, I have a virtual machine running on my computer so I can have the equivalent of 2 or 3 computers running on one piece of hardware. This is what's happening in the world of networking. They're creating a virtual layer on top of physical switches and routers. So you have software defined networking. Okay. That in itself is quite an undertaking to learn. Okay. What other skill set do you really need to know when you want to get into this world? Yeah, you got it. You got to know Linux or some derivative of Linux, because that's what all this stuff runs on. Do you really think Azure runs on Windows, whatever, Windows Server? Of course not. It doesn't scale. They're running on flavors of Linux, and Ubuntu and SUSE play well with Microsoft. So some of the things that are kind of cross-platform-ish are beginning to work really well on Linux. Okay. And that's because Microsoft has learned that they must play well with others. Because I can fill this board with companies that are out of business because they use this idea of vendor lock-in. Vendor lock-in. We get them to use our product and they'll never go to somebody else. Ultrix, CPM, on and on the list goes. Amazon is kind of getting the picture that they cannot be, you know, when you really get good at Amazon and you put your stuff on Amazon and you think, hey, they're getting too expensive, it's very difficult to take your stuff from Amazon and bring it to Azure. Very difficult, not impossible, difficult. However, something that's coming to you, as I mentioned this in the Linux class, there's this layer that's just the top of these clouds. It's called Kubernetes. Okay. And then you spell it K8. Okay. It's a layer that was actually invented by Google and they open sourced it. So if you provision your cloud on Kubernetes, you can move between cloud providers. So one of the things you'll be doing is managing costs for the IT department by moving from one cloud provider to another cloud provider to save money. That is a real job skill. No, we do not teach Kubernetes. We talk about it, but no, we don't. If you're in the program and you take a final projects class, that would be an opportunity for you to actually build out a Kubernetes cluster in the racks in the back room. Okay. So we don't teach it per se. Okay. But there's this stuff, everything I'm talking about, you're going to have to get a job and somebody's going to teach you because there isn't really a class for this stuff. However, if you go to ACM and you click on O'Reilly and you go to their learning path on Kubernetes, you're going to learn Kubernetes. Okay. So there are places to learn this stuff. You just got to know where to look. Okay. All right. So some other things. Let me hit Control C here. All right. Okay. How do we try and get the $250 from the bookstore? The way the vax, that you prove your vaccination status, and I probably should show you, I'll show you what I know. Okay. I don't really know if it's going to, let me share the right screen here. Let's see, I want this one. Okay. Open this up, open this up. All right. So let me go to MJC here. And there it is, this COVID information. I think if you just look up COVID. Yeah, whoops. Let's go back one. There it is. Okay. When we, for campus, when we come on campus, we're going to have to do this health pass thing. And what it does is you download an app, of course, onto your phone, of course. So Big Brother can watch you, of course. And what it does is, let's see here. Let me put in mine. I don't know if you can see this, but what it does, you see a little green thing that says I'm vaccinated. Okay. This credential, all this is run by the IBM wallet stuff. You upload that to the IBM wallet and it's supposed to automatically give you that $250 credit to the bookstore.
I'm going to interject here. I'm sorry, Professor, and say that it doesn't always work that easily. The call that I was on when this course just started in the first few minutes was the financial aid offices. And I'm a dual enrollment student between Columbia and MJC.
Right.
So that made things even more difficult. So yeah, if one side or the other ends up failing, don't be surprised. Just call up the financial aid office or, chat with them and they'll fix it if you've already submitted your documentation.
Yeah, good point, because this is all new this semester. So we've got a lot of new systems that are rolling in and everybody's kind of scrambling. So yeah, call the financial aid folks and they'll get it in. And then if you don't want to take the vaccination, you have to get tested more frequently. So that's just kind of the way life is right now. All right. And let's see. So once you see, if I can find the IBM Health Wallet thing.
If you go for the MJC Free for Me page, they link directly to the Hit Right Secure Force page.
Oh, okay.
Looking at the URL, it looks like IBM's also using Salesforce for this, though.
Yeah, this is it. Healthy returns. What you do is you put in your student email address and you click on record a vaccine. And then you look at your Vax card, you put in your information in, and then they want you to upload a copy of your Vax card. And then you hit submit. And then what happens is once you hit submit and it gets verified, then you click on digital health pass and it brings up an IP address or it brings up I have to wait, go to my email, it sends me a link, and then it brings up a QR code that you scan with your phone saying, and then it puts that in your wallet and ta-da, you've got a little green light that says you're good. You can do the same thing with a test where you put in your test, you upload it, they send you a link to your email, your student email, and then you go back, you click on the link, blah, blah, blah. And then you get a digital health pass for however long it is for the test. Okay. So when we come on campus to do our cable building, we will, wear masks, and we'll have social distancing and all that stuff. So that's why I'm only going to bring 5 or 6 at a time into the classroom. Okay. So we'll get that set up as, probably next week or so. All right. All right. Now, do we have some questions? The in-person classes are going to be optional if you want to learn how to make a cable. Now, if you already know how to make a cable, I'm not going to require you to come in to make a cable. Okay. So if you don't want to come to class to learn how to make a cable, that's fine. Okay. It'll be set up for extra credit. Okay. As far we can get to the racks, maybe that's for the Linux class. I don't know if we're going to be able to do on-site for the Linux class. Good question though. We can talk about it. The problem is once you provision a rack or a network piece of networking equipment on campus, you can only get to it from on campus. And you cannot get to it even from our own wireless. So if you provision a server in the back room, there's only a few machines on campus that allow you to get to the rack. Okay. So it's a kind of a sad state of affairs at the moment. Okay. All right. Let's see. In classes, that's it.
Dr. Phillips, one question I had from early on is I think I heard you mention that you wanted to hold office hours, but I missed the first few minutes like I was mentioning. When were you planning on holding office hours for this course?
Yes, I will be posting those tomorrow because I have to turn them into the division office. We will have office hours via Slack. So I will be on Slack during my office hours. And if you got questions, ping me and we'll go from there. And I've tried to use Zoom in the past, but Zoom times out when there's nobody there. I open a meeting and nobody shows up. It times out after about 45 minutes. So I said, well, need to come up with a better plan. So we'll be using Slack for office hours. So if you have questions that require tech support, we can jump over to Zoom. Slack has the Zoom option. You just type in /Zoom and we'll open a Zoom meeting for you. Okay. All right. Or you can join a meeting from Slack too. Okay. That's all very possible. Okay. So office hours will be Slack. All right. Let's ask a few questions. And from there, let me know, throw some questions in the chat box about anything and everything related to this class. And we'll see if I can answer somewhat intelligently. Okay. As far as what we're doing and where we're going with it, is that networking it starts off fairly simple, but it can get complex. The goal is to give you a real good handle on the foundation of networking. And there's a fellow on campus, his name is Scott, and he's one of our IT admins. He's been in networking for decades. And I'm hoping to bring him in so he can do some demos on a Cisco switch. Okay. And that meeting will probably be not in person. It'll probably be over Zoom somehow. But I need to work with him and find out how he wants to do that. So, because he'll talk about iOS, talk about routing and switching, but you need to understand a few things before we jump into Cisco configurations. Okay. All right. Okay, will becoming campus be necessary if we've learned how to make network cables in previous classes? No, you do not have to come. This is optional. Okay. Is the class going to be, what is this class going to be about? Because I want to enter IT job because like working with computers. Well, networking is how computers talk. It's kind of important. Common enterprise setup, like the mystical 10.xx, things like RFC 1918. Yeah, all about it. Yeah, we'll talk about what those are and what the private IP addresses are, how they work, and why they don't route onto the internet, et cetera, et cetera. Okay. And some of that stuff's kind of hard to demo on Zoom. A lot easier in the classroom. Okay, we'll figure out some ways to do this. Okay. All right. What software will be used other than Wireshark? Commands, NSLOOKUP, DNS, dig, various net tools from the command line. Yes, we'll have a whole section on IP6 and CIDR notation. IP4 and CIDR notation. IP6, it's a different world. It's not exactly the same. There's calculators I can show you.
Let's assume that I can't use a calculator for the exams, if I remember correctly. I've used calculators in the past too for that, but.
Okay, there's a bunch of them out there, and there are slight differences in the way they're implemented, but we'll learn the CIDR notation. Class porting virtual machines. That's a good question. Taking a physical machine and turning it into virtual. Depending on your tool of choice, it can be trivial or it can be complex. But basically, in a nutshell, you take your physical machine, you boot a version of Linux, you run DD, you get an image, you process that image with your virtual machine software of choice, and then upload it into the cloud. Okay. That's a shortcut of the basic process.
A little bit different, Charlie.
Move this app to a new instance. You'll have to define app. Is the app on a server? Is that the only thing the server does? Like Foster Farms consolidated 20 Windows NT machines that were all doing one little teeny tiny thing. So they got rid of 20 machines in one fell swoop. They got one big honking computer, and we virtualized each one of those and turned it into a VM and stuck it on the big box. Okay. But yes, you can take a physical machine and put it in the cloud. If you have an individual app, let's say it's a web server app, it might be better use Docker and put it up on the cloud. We talk about that kind of thing more in the Linux class than we do in this one. Okay. All right. Okay. So if you're in the Linux class, you're going to get your brain is going to get really warm. Your earwax is going to melt. And I think I've gone over. All right. So the class is now technically over, and I will turn the recording off. And if you have questions, feel free to Slack me and we'll go from there. Let me stop the recording.